What kinds of environments or samples can Raman spectroscopy handle more easily than IR, and could this include liquids, solids, gases, or even materials under extreme conditions such as high temperature, high pressure, or aqueous surroundings? Does Raman spectroscopy offer advantages when it comes to analyzing the microstructure of materials, and what exactly does microstructural information refer to? Does it involve insights into molecular geometry, bonding, crystallinity, or phase composition? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does Raman spectroscopy allow us to probe such fine details of structure? Could it be related to its sensitivity to vibrational modes that are otherwise invisible in IR spectroscopy? Why is Raman particularly useful for gaining insight into nonpolar bonds or symmetric molecular frameworks, and does this give it an advantage over IR when studying certain materials? What are the specific advantages of Raman spectroscopy that make it so widely applicable? Could these include non-destructive measurement, minimal sample preparation, and compatibility with in situ or remote sensing analysis? Can Raman spectroscopy be used through transparent containers, like glass or plastic? And how does that enhance its usefulness in real-time monitoring of chemical reactions or in biomedical diagnostics? How does the use of lasers in Raman spectroscopy improve spatial resolution? And does this allow for the mapping of microstructural features on a microscopic or even nanoscopic scale? What role does Raman spectroscopy play in fields such as materials science, chemistry, pharmaceuticals, forensics, or art conservation? And why is its ability to identify substances without altering them such a critical benefit? Could its immunity to water interference give it a significant edge in biological or aqueous systems where IR absorption by water can obscure important signals? Are there any drawbacks or limitations to IR spectroscopy that Raman can overcome, such as difficulty analyzing symmetrical molecules or challenges with sample thickness and preparation? Given all these considerations, is it fair to say that Raman spectroscopy not only complements IR spectroscopy but also expands the possibilities of molecular and structural analysis by providing unique advantages and broader applicability? What does it mean when we say that Raman spectroscopy has low requirements for samples, and why is this considered an advantage compared to other analytical techniques? How does this flexibility benefit researchers and analysts when working with a wide range of materials? What types of samples can Raman spectroscopy analyze? Could it be used for solid powders, and if so, how does it handle materials in fine particulate form without complex preparation? Can it also be used to study polymers, and what does that suggest about its ability to analyze long-chain molecular structures or synthetic materials?